Hello everyone, welcome back. So in the pre-EC2 talk, we have discovered that EC2 instances are nothing but virtual machines running on AWS data centers by a hypervisor called Zen. So what I have known so far, we know that EC2 instances are virtual machines. We know what a region is, those are geographically separate locations, and we have multiple data centers in each of those locations. So the data centers are also called AZs. So this will be our agenda. We'll talk about different instance types, VCP. We'll talk about root device and AMI. We'll have a little demo. We'll talk about Elastic Network Interface and then tenancy, placement group, and pricing, purchasing options. How can you optimize cost? Finally, design patterns using EC2. So let's get started. So we are already familiar with this particular image. We know that this is a server or a hardware, and we can install a type 1 hypervisor on top of this server or hardware. And if you want to launch multiple virtual machines using this hypervisor, we have to provide something called ISO images. So each virtual machine would take one image. So if you want to launch, say, multiple virtual machines with multiple operating systems, we have to provide different ISO images. If all the virtual machines use the same operating system, we'll provide only a single ISO image. So in this example, if you're launching a Windows virtual machine, we'll be providing an ISO image which contains the Windows operating system. So if you want to launch a Mac virtual machine, we'll provide an ISO image which contains the Mac operating system. Similar is the case with Linux. So hypervisor will take this ISO image. So the ISO image is the input to the hypervisor, and output is one or more virtual machines. So where does EC2 fit in this architecture? So in AWS, we know that the hypervisor we use is Zen. Now we provide Zen with something called ISO image. We provide the ISO image to this hypervisor, and Zen launches EC2 instances using this ISO image. So each EC2 instance can have same or different operating systems. All right. Amazon machine image contains information required to launch an instance. This is a very basic definition and does not clear anything. Coming back to the same diagram, we have hypervisor. We provide hypervisor with ISO image, and using that ISO image, hypervisor launches one or more operating systems in virtual machines. So what does this ISO image essentially contain? So far we know that it contains an operating system. So it can contain other stuff also. What if you want to launch a Windows operating system with Microsoft Office already installed in it? Can you have an ISO image for that? Yes, you can have. So if you have an ISO image which contains Windows operating system along with Microsoft Office, and if the hypervisor uses this ISO image to launch a virtual machine, then this machine would contain Windows OS along with Microsoft Office. So AMI is similar to ISO image. It can contain operating system, it can contain operating system architecture, root device, virtualization type. So what kind of virtualization you are using to launch these virtual machines? Something like this. So it can contain operating system, it can contain additional softwares also along with the operating system. So in our case, that means AMI is nothing but an ISO image which is provided to Zen, which contains operating system along with other information. So let's see practically how it works. So this is the screen. aws.amazon.com will take you to this screen, and you have to sign into the management console, and you have to provide your account's email ID and password. So this is the management console you'll get, and there are multiple services. We have already seen this screen. Now I'll look into it in much more detail with each services. So how to go to EC2? The first thing which you have is compute, and in compute you click on EC2 and it will take you to this landing page of EC2. Now there are multiple things here which we'll discuss in due time, but a few important things which I want to show you right away is this region. So this is the name of the account, and this is the region, and this is support. So the most important thing is this region. So if you click on this box, it will tell you all the regions. So if you change it to, if you click on US East Ohio, I'll take you to Ohio region, and whatever you launch, if you launch an EC2 instance, that EC2 instance would be launched in US East 2 or Ohio region. So currently we have chosen US East 1 or North Virginia region. So if I launch EC2 instances, those EC2 instances would be launched or would be started in this particular region. How do you know how many AZs are there? So if you scroll down the screen, you'll see this portion which tells you that how many AZs are there in this particular region. We have US East 1A, 1B, C, D, E and F. So there are 6 data centers or 6 AZs in this region. So if I change this region now, if I go to US East Ohio, so I have changed my location. I have changed my geographical location. Now if I see the screen, if I see the data centers, the number of data centers are these 3. US East 2A, US East 2B and US East 2C. So there are 3 AZs in US East 2 or Ohio region. So let me go back to North Virginia. Okay, having said that, let's go ahead and launch an instance right away. So click on this launch instance button, and the first thing it tells you to choose an AMI or Amazon Machine Image. So I have already told you that Amazon Machine Images are nothing but it is similar to ISO image, which contains operating systems along with other softwares. So which operating systems? You can choose Amazon Linux, you can choose SUSE or SLES, you can choose Red Hat Linux, Ubuntu, Windows Server, etc. etc. So these are the operating systems which all of these Amazon Machine Images or AMIs contain, and contain some additional softwares also. So if you look at this description, it says that this AMI is an EBS-backed AWS supported instance. It includes AWS command line tools, Python, Ruby, Perl and Java. And the repositories include Docker, PHP, MySQL, PostgreSQL and other packages. So that means this image not only contains operating system, it also contains additional software. So if you use this image and ask Zen to launch an EC2 instance using this particular AMI, then it will of course have Amazon Linux operating system. Along with that, you'll get Python, Ruby, Perl and Java softwares also. Similar is the case with this one. If you choose Red Hat, then you will not get anything apart from the operating system. You have to install each and everything. If you choose SUSE Linux Enterprise Server or SLES, it will give you the operating system and that's it. You will not get anything. So Amazon Linux will contain additional softwares along with the operating system as well. So we'll choose Amazon Linux as our AMI. So when we launch an EC2 instance using this, we should have Amazon Linux as our operating system in the virtual machine. Okay, then it asks you to choose an instance type. What is an instance type? So instance types. What happens is, if you think of your corporate environment, your on-premise data centers, you can have different type of applications. You can have ETL application like Informatica. You can have a reporting application with Cognos. You can have a database application wherein Oracle might be installed. You can have a web server or web service application with Java or Python. Now the requirement for each of these applications are different. When I say requirement, I mean resource requirement. That means Informatica, which is an ETL tool, might need a lot of CPU but not too much of storage. Database like Oracle needs a lot of CPU and a lot of storage as well. If you are running a web service or a web server, you might not need that much of CPU and RAM. If you are hosting an online portal, then you might need a lot of CPU, RAM and storage for that particular application server. So your server requirement or your resource requirement changes as per your application requirement. So for some servers you need say 256 gigs of RAM, 8 gigahertz of CPU and say 1 terabyte of storage. For some applications you might need 16 gigs of RAM, 2 gigahertz of CPU and 100 gigs of storage. So you have different servers with different resource requirements. Instance types give you that different resource requirement. So you have different instance types for different types of applications. So instance type determines the hardware of the underlying host computer on which EC2 instances are launched. These are segregated into compute memories, storage optimized, general purpose, etc. types. Let's go to the console and see what does it mean. So this is the screen where you choose an instance type. If you see, there are a few things. It asks for a family, instance family, then instance type, then vCPUs, memory, instance storage, etc. etc. So let's talk about these two things, instance family and instance type. What is an instance family? So there are different types of families here. Now if you see, we have general purpose. All these instance types belong to general purpose family. Then we have compute optimized. So these instance types belong to compute optimized family. We have FPGA instances. It's a family. GPU graphics is another instance family. GPU instances is another instance family. We have memory optimized instance family. And finally, we have storage optimized instance family. So what does this family mean? So if you talk about compute optimized instance family, that means if you choose an instance from this family, that EC2 instance would have better compute power or better CPU power than any other instance family types. Similarly, if you choose an instance from, say, memory optimized instance family, then those instances will have faster memory or better memory compared to other instances. Why do we have different types of family? Because the use cases of memory optimized instances are different than the use cases of compute optimized instances. For example, if you have a workload which needs more CPU than faster or more RAM, then you would go for compute optimized instance family. If you have a workload which needs more memory and faster memory but not so much of CPU or compute power, then you'll go for memory optimized EC2 instance family. Similarly, if you need faster and good amount of storage, you need faster IO operations, faster throughput performance, then you'll choose storage optimized instance family. Then we have instance family types. Each instance family has multiple instance types. These are instance sizes, starts from nano to goes to 16x, 32x. So similar to t-shirt sizes, we have small, medium, large, extra large, double extra large, etc. etc. Now if you see, each instance types CPU and memory are different. So for example, M5 2x large has 8 vCPUs and 32 gigs of RAM, but M5.x large has 4 CPUs and 16 gigabytes of RAM. So as size increases, your resource capacity also increases. So in this case, CPU and RAM. Now let's see a little bit of tricky stuff. Concentrate on the instance types which I have highlighted here. M4.4x large, which has 16 CPUs and 64 gigabytes of RAM. C5.4x large has also 16 CPUs but 32 gigabytes of RAM. The sizes are different, 4x large and 4x large, but they belong to different instance family. C5.4x large belongs to compute optimized and M4.4x large belongs to general purpose instance family. So in compute optimized, we have lesser RAM, 32 gigabytes of RAM, as opposed to general purpose, but the number of CPUs are same. So how come compute optimized is a compute optimized instance if the number of CPUs are same? This is where the processor generation comes into picture, which we discussed way back. So the 16 CPUs which C5 instances has, that is faster and a generation ahead than that of M4 or general purpose instance types. Similarly, if you take another example, R3.8x large and D2.8x large. Now both of them has almost similar type of CPU. R3.8x large has 32 CPUs and or vCPUs. D2.8x large has 36 vCPUs, but the amount of RAM are same. So if RAM is similar, how come R3.8XL belongs to a memory optimized family, whereas D2.8XL belongs to a storage optimized instance family? This is where the type of RAM comes into picture. So memory optimized instance or R3 8x large has faster RAM than that of storage optimized. Even though they are using same amount of RAM, the RAM technology and speed might be different. For example, R3.8x large might be using DDR3 RAM and D2.8x large might be using DDR2 RAM. So DDR3 is faster than DDR2. So that's why this belongs to a memory optimized family and this belongs to a storage optimized family, even though the amount of memory or RAM is same in both the cases.